Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. Today we have another Bass3k amplifier in for repair with the good typical shorted power supply section. This one is not in as bad a shape as others that I have repaired, but still it will be quite interesting to repair this power supply and just to go over the typical things that you want to look for during this. Is this R150 resistor here, I think I've pointed this out in previous videos, also does open during that particular fault of the power supply like that. This provides the voltage back to the IC that drives the power supply. Well, it's a gate driver IC, I should say, because this IC really drives the power supply, but this is a gate driver IC, so sometimes I have to replace this IC also. But usually when this thing opens up, the rest of the circuit's protected. So what we're just going to go through, we're going to remove the transistors, we're going to clean up the soot from the cooked transistors here, and we're just going to see what kind of damage we have on the traces of the board. Because the first thing we want to do is determine what do we have to do to the board itself to repair this thing. So I have my Hakko FR301 here warming up for us today. Sorry guys, I know it's been a while since I got a video out. I have been a little sick, but I think today I can talk a little better. So please excuse the noises of the desoldering tool here. I'm just going to run through and buzz these things right on out of here. Now, when you cook this, this lead-free solder, when it gets cooked like that, you may want to take some fresh solder and go back over the trace just a little bit. Because that lead-free solder, when it burns up, it turns kind of crispy, where it makes it kind of hard to get back apart. So, oh, that's cool. This got so hot that it actually desoldered the leg of that transistor. That's cool. As I digress from what I'm doing here. And we're just going to pull these transistors right on out of here. Now, I did release a little short 1-minute video that was not done in OBS, and I think what I've realized is I have been changing the color. Oh, pieces. I've been changing the color because what I see on the screen is not what I prefer to see in my videos. But come to find out, I think it's the screen of my computer that's giving me this such a blue hue in the video, but yet it comes out just fine when I upload it. So I'm going to try this without changing any of my color settings and see how it turns out. Now sometimes when these things are burned up to a crisp, you literally just gotta peel it right on out of there. You want to be careful though to not pull up the traces too bad on the bottom side of the board. Granted, we are probably going to be repairing the traces. You just don't want to cause any more damage than is already there. This amplifier belongs to another fine customer of mine that that you'll see in live streams every now and then. One, thank you for your continued support of Ellensburg Amplifier. Just felt something a little crunchy underneath there. And as requested, I am making a video of this repair because he has requested a video. Wow, it even unsoldered that one too. Ain't nothing like the smell of a crispy PCB. Because this is crispy. I repaired a Bass3k a couple weeks ago that it was in really bad shape, and it actually turned out pretty decent. I'll show you guys a new, I call it a new product, a new method that I'm doing now for PCB repair instead of using 2 parts. Kind of stepped away from using 2-part just because of the time it takes to do repairs with 2-part. So we're just gonna peel all this burn up stuff right out of this board, which will allow me to inspect the traces, the surface of the board, the vias, any other high heat damaged areas. And since the Hakko FR301 is on and hot, we're going to check the output transistors and see if we have any shorts out there. Rectifiers, pretty obvious, comes off your power supply. So your output transistors, we know this is not gate here because it is connected to ground. So, and I take my negative lead of my meter, I am on resistance, and I use my negative lead on the ground and my positive lead on the source. 10K, 11K, 10K, 11K. 9 times out of 10, when you read your 9 to 11K on these, your output transistors are still okay. I'm just going to check a drain to source here real quick, just to make sure I don't have any drain source shorts. It is kind of rare that I've seen to have a drain source short and not damage the gate. The gate itself, in my opinion, is one of the more sensitive spots of a transistor. All right, so that's what we have. We got the transistors removed. My camera's a little upside down. One day I'll have this all figured out, how to get everything, all the views correct, so you guys can see a little bit better. I don't have my Samsung, whatever, this real fancy camera. I don't have that running right now, just because I don't have a lot of time to get that all set up. So I'm just going to take some isopropyl alcohol, and I'm just going to squirt it onto the board. And then I'm going to take my toothbrush and real gently, I'm going to go over the area that burned up. Sometimes these will burn up so bad where if you take your toothbrush and you start scrubbing away, you're going to start peeling up these traces. So I like to keep it a little bit more cautious at the beginning here, just to see if I have any loose traces. So far, it doesn't look like it. The isopropyl alcohol that I'm using right now is 70%, so it is a little lighter. I use the 70% as just my general all-around cleaning of boards. It still works really good to clean them up. And if you have any residual charge in your capacitors, or not even on this particular board, but any board that has a lot of capacitance, you want to kind of be careful when you're using the higher percentage isopropyl alcohols, like the 99s or the 91s. Because a little bit of spark, you could potentially have a little bit of a flame issue. So then I'll use my 91% here with a Q-tip to really just kind of get in there now and see what I'm working with. I kind of wonder, that's strange, the gate drive IC does not have a hole in it. But you know something shorted because it took out the resistor. Usually that gate drive IC's got a big old hole right in the center of it. All right. What I'm going to do is I'm going to flip this around and show you, since my camera's on the other view there. As you can see, we have the gate drive IC. And you're going to have some capacitors there. And you can see what I'm dealing with, just some black areas of the board. And what we're going to do is we're just going to check and see if any of this goes into the PCB. And it does. So I can actually dig the tip of this tweezer right into the board. So we do have to get rid of this carbonized PCB that's in between these vias. If you were to take a real fine point on your meter lead and test, you will actually read resistance through that carbonized PCB. And that's what you don't want on anything that has any sort of transistor. Oh, that trace right there is, of course, delaminated from the board. Which we may be able to save. It just depends on how you isolate these vias from each other. And I will show you a neat little tool that I have now that I use to get in between these vias. And you can see even the tip of my tweezer is just barely small enough to make it in between those vias. But the tool that I have is small enough that it'll go right in between there. So what I'm going to do is I'm going to flip it over and show you guys what I do. Let me get my handy new little tool. NFV2, thanks to Alex there at Northridge Fix. I have purchased this from him. It's one of the more handy tools to do this real fine, small work right here versus, of course, the full-size Dremel. So I got to put on my helping eyes here because I'm not blind, but I do have bad vision, bad eyesight. So, and you know, a lot of things you will find down below in links on my affiliate account through Amazon. So if you have any interests in the items that I use that I mentioned, just look down below and you can find a link to it. So I'm just going to Dremel in between these vias. Now this is where a person could, you know, use a microscope, but I find if I just throw my helping eyes on, I can get it done pretty quick. Yeah, this via here, this one's pretty bad. That's pure carbonized board that I'm drilling out right now. So the biggest things you want to be concerned about is the gate of one transistor and any neighboring transistors. You want to make sure that that gate is clear from any stray signals. That's what I like about how these are built. They're spaced out pretty decent. So as long as you get rid of the carbonized board, you shouldn't have any issues. Remember, the goal is to isolate. And I'll just get right in between each via and start drilling it out until I see clean PCB board, which would be a white color, tannish color, and not black. So like I said, you really want to make sure the gate and drain are independent. And every now and then, as you see, I just take my good old trusty toothbrush here and clean up the area that I'm working on until I Dremel it out until I see the tannish PCB. When you see that tan PCB, then you know that that trace is going to be isolated from the other via. And we're looking pretty good now. Yeah, this dandy little tool sure makes quick work of trace repair. Oh, excuse me, guys. You'll have to excuse me. I'm still trying to get over a cold. Well, I don't know what it is, but it's definitely a nasty one. So now I'm just going to go from the top. Just to double check that I'm clear. Again, I'm just looking for that tan color. All right. And that is that NF V2 tool. It's a dandy little tool. I like it. Charge lasts a long time. And you can get extra tips, and even some of the smaller Dremel tool tips that you can buy will fit that tool. And now what I'm going to do is I'm going to check resistance. Remember, burnt PCB does introduce some resistance, and we don't want that. We're looking great. Looks like I have isolated the problem areas. All right, so excuse me. I think the next step here is we're going to go ahead and check the capacitors. We're going to see, make sure I don't have any shorts across capacitors. We're going to pull the IC. I'm going to check the two 1K resistors that are above the drive IC, gate drive IC. The 10 ohm snubber and the other 10 ohm snubber. Make sure the capacitors on the snubbers aren't shorted. It almost looks like this was hooked up backwards. Almost does. All right, the other 10 ohm resistor, right on. Perfect 10 ohms. Good. Excuse me. This capacitor here might be short. I'm reading. Nope, it's good. All right, it's good. Not short. So the snubbers are good. We're going to remove the gate drive. We're going to remove the gate resistors. Of course, they're going to be out of tolerance. What is the value of these resistors? 4.7 ohms. All right, so 4.7 ohms. We're going to go ahead and pull all the 4.7 ohm resistors off and the drive IC. Let me see if I can get you a little bit better view of what I'm doing here. There we go. All right, so we're going to fire up the hot air station here. This is the ST862D hot air station, which is, in my opinion, far superior to the Xtronics. Excuse the background noise because of the hot air. And we're just going to remove the gate resistors here. I'm going to leave the pull downs in. Make it as quick as possible. I don't want to damage any traces. And the IC. As I say, piece of cake. If you have the right equipment, you can make these repairs relatively easy. I don't say, or not as time consuming. So having the right equipment really does significantly reduce the time spent repairing amplifiers. Now there's a trace right here. Let me see if I can get you guys a little closer. Is it gonna focus? Why does that focus look so off? All right, hold on. What's going on with my... Maybe it's just because I'm still ill. I'm not sure. It's on autofocus, so maybe it's focusing on the wrong thing. Autofocus? Oh no, it is on. Okay. It's just looks like it's focusing on the wrong thing. So let me see if I can manually focus this in on what you guys are wanting to see. Let's go here to focus. Ah. All right, let's make this better. There we are. Maybe. That's pretty close. All right. Oh, there's the heater coming on in the background. All right, so there's this trace right here. This one that falls right at the back of the board. I can get my tweezers right up underneath that, which, well, is bad. Because if we break this trace, it goes to this gate resistor pad here. We want to try to leave this intact as much as possible. So I'm just going to flake away all this burnt crispiness here. Because what I want to do is make that secure again. I'm going to get a little bit of isopropyl alcohol here and clean up again. Now that we have some stuff removed, I'm just cleaning up over here back where the IC was. That's slightly out of view. I want to make sure there's nothing hanging around that's going to keep me from adhering traces back to the board. And you'll know because your Q-tip will start to come up clean. And you could sit here and scrub at this stuff for quite a while. It'll come up, but my goal is to fix that trace before it gets away from me. I'm sure I can fix it, repair it, run new traces and stuff, but again, I did not quote this as a trace repair. So I will glue it back in place. Now I'm going to bring this camera up a little higher here so you guys can see what I'm going to do here. All right. My new method. Let's see here. We're dealing with a green board. So I'm going to add a drop of green into my little cup. And then I'm going to put a little bit of UV curing liquid. UV resin. And I'm going to mix up that UV resin with my green dye. Now, I'm not sure how many of my viewers watch Northridge Fix, but Alex, this one's for you, for sure. So I'm just going to take some of this UV resin here, and I'm going to apply it right to the top of this trace. And I'm going to get it up underneath that trace so I can kind of float right up in there. Looks like I have some Q-tip left over hanging around here. Oh, sure do. All right. Just like that. And then I'm going to take this and I'm just going to get rid of the UV resin that is all over the board. And this is why I have gone to using resin, UV resin. All right, guys. Now I'm going to get the old UV light going. So I'm just going to cure this up real quick. And you'll see that that trace will no longer move. This UV resin cures up, in my opinion, a lot stronger than 2-part. So just make sure you don't get this UV resin anywhere where you don't want it, because this stuff is, if you get it to where you don't want it, you're going to have to use a Dremel to undo what you did. Just like that. Rock solid. Super fantastic. So that trace is not going anywhere now. Simple as that. And really, what I do is I'm going to put the new transistors in place. I'll solder them in place. And I'm going to do the same thing. I'm going to take that UV resin and I'm going to go right down in the cracks that I just dremeled out in between the vias, and I'm going to resin those up and cure those, and it'll make this section here just rock solid once again. And it also acts as an insulator in between the slots that you cut. So the only thing I would mention about doing this is not to add too much coloring to your UV resin. I use pigments. You add too much to it and it'll come out kind of sticky. So it doesn't take a lot to color up the resin. And what I like about this versus 2-part is I can set this aside and finish my work, get the transistors in, soldered in place, and I can still use this. Now, if this was a 2-part in 5 minutes, you wouldn't be able to use this. So, that's right. UV resin is, in my opinion, is the way to go. So these use the STP 180N4s, which I do have the STP 180N4s. Let me go grab some and I'll be right back with you. And I'm going to grab some 4.7 ohm resistors. All right, I am back. I've got some transistors here off the side, and I've got my 4.7 ohm resistors. And let's and let's get these gate resistors back on. I like to take care of them first. That way I'm not having to work around the leg of the transistor. Just a little bit more room to work with here. So what I'm going to do is I'm going to solder those in place, and then we'll get the transistors put in. All right, I got those resistors soldered in place. Sorry, I didn't do that on camera because I didn't want to know if you guys want to see my head above that camera there. I have to get kind of close because these resistors are small, as you can see here. So what I'm going to do is I'm going to take the transistors and I'm going to go ahead and bend them in place. So I just slightly stick the leg of the transistor in the view hole with my finger underneath, and then I just do small increments, bending the legs over. Gives a nice sweep on those transistor legs. Hopefully that I can get, there we go. I'm not sure, but I think the via for the gate might be open. There we go. And I'm just gonna do the same, just small increments. Yeah, that via there it's damaged pretty good. Yeah, same with that. The gate vias are kind of bad shape, but never fear, by the time this is done, it will be perfect again. Yeah, it looks like the gates had kind of a rough time. Which is pretty standard, typical on amplifiers, is that you'll see that the gates take just a huge hit when an amplifier goes down. Now, I've seen amplifiers come in where they've taken these transistors and bent them just straight over, and it puts so much stress on those legs. I would much rather have, you know, a reliable amp than something that is just thrown together. Which is why you see pretty meticulous on how I do things. All right, let's flip it over and solder these in place. My good old spool of solder here, which again you can find down below in the links, Amazon affiliate links. It does help support the channel. I do thank you guys for all the channel support, as usual. So what I do is I just go through and I solder one leg first. It just kind of holds things in place for me. Just want to make sure the transistors are lined up nicely. Using the FR301 as a soldering iron. Works great. I love it. It's fantastic. Great all-around tool, as I always say. You know, when you do this stuff every day, you got to find what works best for you. I like to make sure my transistors are straight and as even as possible. That way the next person that works on it says, oh hey, some nice work has been done here. And I'll say, thank you. Now this gate here, probably we're going to be soldering from the top because the via itself is gone. That's okay though. The nice thing about the gate end of the transistor is you kind of want that to open up pretty quick on a fault. If you start changing wattage size resistors at the gates and stuff, and there's a failure, you're gonna really gonna cause more damage down the stream of things. That's why you'll see gate resistors being, you know, quarter watt on a big 16K amp. You kind of want those to open up relatively quick. All right, so we're back with the transistors here. I just want to make sure everything's straight again. And then I'm going to go through and I'm just going to touch the top of the gate pad with the little Dremel tool here, just to expose some good pad for me to solder to. Remember, this lead-free stuff, when it goes up, it kind of disintegrates. Makes it real hard to solder to. So I just want to make sure I have something good here at the gate, because if you have a bad gate signal, that transistor will go up in smoke. So I'm going to solder up these gates real quick, and we'll move on to the IC, and we'll change this resistor here, and this thing should be good to go. So I'll be right back with you in just a minute. All right, I got the gates done, and of course, as most all Taramp boards, I go through in the drains. I also solder the drains just to help reinforce this, because these transistors, these 180N4s, they can handle just a ton of current, and you'll melt everything before those things will burn up. That's why all these 3Ks here, you'll see burn up traces, because These 180s are just brutally big. So I'm going to clean up the flux that I just put down to help flow the gates in place and the drains of that transistor. Just going to clean it up here real quick, because now what I got to do is I got to glue these down in place. The gate area itself. That way we don't lose a gate from any vibration or anything of the sort. And you know, I'm not bashful with Q-tips. Q-tips, in my opinion, are one man's best friend here is the Q-tip. You can get in, kind of get what you're after here. So I'm going to check resistance first before I put that UV resin down, because I want to make sure that my gates are in fact the 4.7 ohms. 4.7, 4.7, and 4.7. So all the gate work that we just did is successful. You always want to double check your gate resistance too before you start boards up, because if you're missing a gate or you didn't make a good solder joint or anything of that, and you fire this board up, that transistor will either get smoking red hot or it'll just pop on you. It depends on how much current you're putting into it. So you always want to make sure that your gate signal is as good as it's going to be. So this is not saying that if this burns up again in the future that this damage will get worse. I mean, there's a high probability that, of course, it'll have more damage if this burns up again. So I'm just going to take my green resin here, turn on my UV light, move my little cup away from the UV light here. But what I'm doing is I don't want that resin to drop down and drip down past that crack, that little slot that I drilled. So I just real quick, like, I put some resin on there and then I cure it up before it has a chance to flow down in through the board, because I'm going to actually fill it from the bottom. Right now I'm just protecting the area where the gate resistor is, because I don't want that to move. Again, you get vibration damage on a gate resistor and it pops loose, you will lose the transistor. And it's just that quick with the light. And then I'm going to do some right at the bottom of the gate resistor here. My goal is to make sure that that gate resistor is held in place. So we're looking pretty good, pretty decent. That's what I like. And then I'm going to, since this is green, you know, this will help kind of blend in on the color of the board. We will cover up my repair areas here. As you can see, I just go back and forth, which is much quicker than, again, than using two-part. Then I'm going to flip it over, and I'm going to finish the Dremel areas that I did. So if this were to ever burn up again in the future, it will smell bad. And then this gate leg here, where the gate via literally is gone, I will cover it. And yeah, guys, you will not have any UV light coming through your screen on your computer or phone or whatever you're using right now. You have to, and that's the thing is, you know, people have not explained why you don't get this UV light through your screen. I've heard people say you won't get harmed by it, but why? You know, I'm a why kind of guy. Why do amplifiers fail? Well, why can't you get, you know, UV light through your phone or through your laptop, through your computer? Well, here's the answer. Your phone doesn't have UV LEDs or UV OLED screens. Your laptop doesn't have UV LED. Your computer screen doesn't have UV LEDs. You got to remember it's RGB, red, green, blue. That's what you see. Now, I'm not sure about the OLED screens, you know, how they're designed, but come on, guys. You don't have UV LEDs in your screens. We'd all be blind. Well, no, I probably wouldn't say blind. We'd all have problems if we had UV LEDs in our screens. So, looking good. Now, is it solid? Solid as a rock. Solid, solid, no legs are moving, no legs are moving, no legs are moving. That's good. That's what we're looking for. I want to make sure that if I move this transistor that I have no movement in my gate resistors, which I have zero movement anywhere. So that is what I call a, let's see if, can I get this back into view for you guys? This is, as you can see, you can move that transistor and you don't have any gate movement. So that's what we're after, 100%. With two-part, that will move a little bit. And then when I'm done with my little cup here that has a little bit of green left in it, I just take my lamp and I cure it in the cup. And then I just peel it out. So this stuff is fantastic. Of course, don't take this big old flashlight, of course, shine it in your face, but I could not stress more when it comes to time and the process of amplifier repair. Find what works best for your situation. And just like that, it cures right up, comes right out. So I'll set that aside. I mean, I repair about 5 amplifiers a day. And I do it 6 days a week. So I have to find the method that works the best. And there it is. So I'm going to be soldering that IC in off camera because I have, over there is my micro soldering station to do these small ICs. Oh, we have one resistor. So we're going to go ahead and pull that resistor off. I do believe that is a 10 ohm resistor, 4.7. I think it's probably 4.7. I'll know in a second here if it doesn't break in half on me. Can't remember if it's 10 or 4.7. Let me just take out the old magnifying glass here. That is a 10 ohm resistor. So we're just going to get a new 10 ohm resistor real quick. A 10 ohm 1206 resistor goes there. And we're going to put that resistor in place. That resistor will supply power to that IC. Or is it the gate drive? Yeah, and that resistor 98% of the time burns up. So over time, you just learn what to look for, what to watch for. Amtech Flux there for you guys. I don't think I have I'm not sure if, I think I have a link to the Amtech Flux. I'd get my flux from Louis Rossman, but he, I think, has moved to Texas. So and when I looked on his site, he was out of stock. So unfortunately, I had to pick it up from somewhere else, and who knows if it's fake? I don't know. Could be. Louis needs to just get his stuff back in stock. Thank you, Louis. But I do, this is probably fake, I'm not sure, but it is the NC559 V3 TF Tachyflux that I had purchased. I know. Slap my hand from Amazon because I need more flux. When you run a business and you run out of something, you got to get it what you can get where you can get it. So just like that, we're just ready for a new IC. We could, in reality, let me see here. Backwards. We can see if all right, so sorry about that. As I was saying, I am going to solder this IC back in off camera because my micro soldering station, like I said, was over the other bench. And I got that resistor soldered back on, so it supplies power to it. So we should be good to go. So I will be right back with you guys, and we will get this thing up and running. I'll be back with you in just a second. All right, guys, I am back. I got this IC soldered in place here. Let me find my tweezers here. So I got this IC. It's kind of right behind the transformer here. I got that soldered in place. Again, guys, you know, these ICs are small. These are the MSOP ICs, so having the right equipment really does help. So I do have the power hooked up right there, as you can see, and what I don't have is a scope up for you guys. That's That's a bum deal. I'm going to set up the voltage, DC voltage of 1 meter to the output terminals of this amplifier. Because what we're going to do is we're going to start this thing. Oh, what is this? Is this amplifier missing a bunch of screws? No, they're just not. They're just screwed out. Let me see here. I need to find a way to prop up these probes here. Nice. DC volts. So, the power, the 12 volts is on. So we don't have any shorts on the gates. These aren't heating up. If you had a problem with the gate circuit itself, you would probably start to feel some heat building up on these. I'm using a 10 amp current limited supply, so these 180s would start to heat up pretty good if there was a problem with the gate. And right now there's no issue with the gate. So let's see if we get a blue light on this thing. I'm not sure if you guys are gonna be able to see that on screen or not, but let's fire this thing up and see what we got. I don't even know if we have any switching. We're gonna find out. Shall we pull up the meter here just in case? Let's go ahead and Rigol scope. Select USB, search, DS, select, and let's get it up on the screen here. There we go. All right, so we got the scope up on the screen for you guys. Let me get the probe somewhere around here on my bench. Oh, covered in thermal paste. My most favorite thing to be covered in is thermal paste. And let's see what we got. I'm kind of multitasking this one because I trying to catch this all at one time here. So I'm on the gate of an output. Well, let's go ahead and give this thing some power. Oh, but let's change the scope settings. 2 volts is not going to work for us. Let's see here. What's our capacitors? Our capacitors are 100 volt. So we're going to go up to 20 volts per division. Did I just see the screen glitch out on me? Yes, it is. So we're going to go ahead and get this done here real quick. Let's see what we got. And there it is. We do have switching, although my pulse, my time base is off a little bit, but we do have switching there. And I have 0.009 volts DC offset, which, hey, I can't complain about that. I've seen amps as high as 2 to 3 volts DC offset. Orion, hint, hint. So yeah, so this amplifier is up and running. Power supply's done, power supply's rebuilt, up and running. The DC offset's been checked, 0.009 volts DC offset. And we have verified that we do have output switch on both ICs. So there it is, guys. Another Bass3k saved from the landfill. Sorry for those screen glitches too. I do thank you guys for watching. If you like this content, please like and subscribe. Leave some questions down below if you're interested in amplifier repair. You can see my mess here. And of course, down below, I do have affiliate links to any items, that I use that I feel is important for, just quality components, tools, equipment of the sort. I have been doing this for quite a while, so there is some good equipment out there and there's some bad equipment out there. Oh, and I'm going to replace this capacitor. See that, guys, on the screen? You can see it's slightly bulged right there. I'm going to replace that too. I just noticed that. So I'm going to get that done too. So I do thank you guys for watching. Please keep your fingers safe with the rectifiers. This is rail voltage. The rail voltage can get a little snappy. So stay safe, guys. And I will catch you on the next one. Thanks a lot.